In order to learn implicit differentiation, we must first review the chain rule. The chain rule states that when we have a function within a function, what we do is we take the outside function first, which is 3. Pretend this is an x, so we have 3 times x squared. We bring the exponent to the front and multiply. So this is 6 times 2x, and we reduce the power by 1. Then what we do is we multiply by the derivative of what's inside. Well, the derivative of 2x is 2. And then my final answer, I bring 2 times 6 is 12, times 2x is 24x. What we have here is the equation of a circle with a radius of 5, but it's not solved in terms of y. There are times where you can solve for y, and then there are times where you can't. This allows you to find the derivative of this equation without changing anything. And we start this by taking the derivative of each term individually. Now, when we are to take the derivative of x squared, that's simply 2x plus. Now, when we take the derivative of y squared, we're going to treat this as if it's going to be the chain rule with two separate functions, with the y itself being a separate function. So if I take the derivative of y squared, what I'll get is 2y. And then I need to take the derivative of what's inside, which is just y. So I'm going to take the derivative of y with respect to x. And then finally, on the other side, the derivative of a constant is just a 0. Since what we're trying to do is find the derivative of y with respect to x, I need to move all of this to the other side. I start by subtracting 2x from both sides. Then I'm going to divide both sides by 2y. And then once we simplify, we get minus x over y. So this is our final answer. For this next example, we're going to have a couple extra steps. Our first term is just in terms of x. The second term is a product between an x term and a y. And then the final one here is going to be in terms of y. So once again, we're going to take the derivative of each term in terms of x. Now we take the derivative of each term. The derivative of x to the fourth is 4x to the third. The derivative of the following product uses the product rule. The derivative of a product is equal to the first times the derivative of the second plus the second times the derivative of the first. So we have the first times the derivative of the second, which is just y, so we just write dy dx, plus the second times the derivative of the first. Moving on to the next term, the derivative of 3y cubed, we use the chain rule. So first we take the derivative of 3y cubed, and then using the chain rule, we take the derivative of just y, which is dy dx. And the derivative of a constant is just 0. Now all the hard work is done. Now what we need to do is we need to isolate the dy dx. So let's do some algebra here. So the first thing I want to do is subtract the 4x cubed and the 3x squared y. We'll move that to the other side. Once we subtract that, we get x cubed dy dx plus 9y squared dy dx equals minus 4x cubed minus 3x squared y. Now, since both of these terms have a dy dx, I can factor those out. And simplifying that, inside I have x cubed plus 9y squared. And if I divide both sides by x cubed plus 9y squared, the entire left side will simplify to just be dy dx. And this is our final answer. Looking at this next problem, we see that we have the product rule appearing 2 times here, but it still works the same way. First thing that we're going to do is take the derivative of each term individually. So using the product rule, we take the first times the derivative of the second, plus the second times the derivative of the first. We repeat the product rule for the next term. So we take the first times the derivative of the second, and we have to use the chain rule after the 2y, putting in a dy dx. Moving to the second part, we then add second times the derivative of the first. But we don't really need the 1 there, so we can get rid of that. And then finally, on the right side, the derivative of 3x is just 3. Now what we want to do is isolate the terms with the dy dx will stay on the left, but these other terms over here, I can subtract and move those to the other side, and I'll simplify them at the same time. So this is 2xy. And the same thing for the y squared. Now we see on the left side that we're able to factor out a dy dx from both of these terms. And when I do that, I have x squared plus 2xy in parentheses, so now I can divide both sides by that. And then on the left side, when that cancels, it simplifies to just be my y prime dy dx. And our final answer is here. This practice problem for implicit differentiation will use trig functions. So first thing that I want to do is want to get rid of this 3. So if I divide both sides by 3, I'm going to get, if you need more practice finding the derivatives of trig functions, there's a video linked at the end of this one. So to do this, I'm going to take the derivative of both sides. So taking the derivative of this, it's going to use the product rule. So I take the first times the derivative of the second. I have to put a dy dx in there. Plus the second times the derivative of the first, it's cosine x, equals, and the derivative of a constant is 0. I need to keep the term with dy dx on the left, but I can move the tan y cosine x term to the right. And then in order to isolate the dy dx, I divide both sides by sine x secant squared y. And then the left side simplifies to be just dy dx, leaving us with this for our final answer. In this last example, I wanted to put one in that uses the quotient rule. And for the quotient rule, there'll be a video linked at the end, but for right now, I'll just write off into the upper right-hand corner the formula for the quotient rule. So it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. So let's apply that to this over here. So in order to do this problem, the first thing we're going to do is take the derivative of both sides. So applying the quotient rule, so I have the denominator times the derivative of the numerator, and this is using the chain rule, so the derivative of y from inside is dy dx. Then I'm subtracting the numerator times the derivative of the denominator. That whole thing is over the denominator x squared squared, which is going to be x to the 4th. And the derivative of a constant is 0. Now I can immediately get rid of the x to the 4th by multiplying both sides times x to the 4th. And that leaves me with, then I need to isolate the dy dx, so I'm going to add y squared times 2x to both sides. And then further simplifying, I divide both sides by x squared 2y. So on the left side, dy dx is isolated. And on the right side, we have some simplification. So we have final answer is y over x.